So Sally buys a machine for printing brochures. The machine is purchased for $17,000. So when they say a purchase price, that's always when we talk about it is a VO or an original amount. And she prints 25,000 brochures a year. The value of the machine is depreciated using the unit cost method. So they're always going to tell you what method you're using. So here I know the unit cost. So I've gone to my formula sheet and I've found the unit cost formulas. So we've got this summary sheet on our notes, and this column here on your summary sheet is the recurrence relation formula, and then this column, this is the nth term formula. Okay, so we have them all listed out. So I know I've got to use unit cost, so I'm looking at these formulas. Now it says the machine reaches a scrap value. So when something depreciates, that means goes down in price, they call the reduced price a scrap value. So it's got a bit less, and that's the word they'll use. So they told you that the scrap value after 5 years was this. Okay, so a rule for the value of the dollars after N brochures are printed. Now that is a way of saying the nth term formula. So we want to look at the nth term formula. So we're looking at writing this one out. And you can see when it says, what it says to do is you write Vn. Now you have to fill in what VO is. So in this scenario, VO is 17,000. Then we've got minus, now it's N times D. So I don't know what that is as such. So if I look over here, it is telling me a formula for D. And it says there that D equals the amount it's depreciated. So I know how much it's depreciated in 5 years. So if you look at it, it was at 17,000 and then it depreciated down to 2,000. So if I do 17,000 minus 2,000, would you agree it's dropped or depreciated by 15,000? Would you agree? Yep. And the formula also says over the number of uses. So this was 5 years. This is how much it dropped in 5 years. So how many uses did it have in 5 years? It was 5. They told me up here it was 25,000 every year. So I'm going to say 25 times 25,000. So if you do that, what do we get? I'll just write that in. So pop that into your calculator. And I get that to be 0.12. So for every brochure printed, it's 12 cents. So going back to this formula here, this will be 0.12N. Now, which is the one that has that answer? E. Good. So you could have, what you could have done, and this is what you need to start looking at, is that we knew that it should have VO, which is 17,000. So you would have been able to cross out all those three. I'm crossing out that one there because it's got N in that. We don't have that in our formula. It shouldn't be there. So you got down to 2 selections. So it just shows you how you could quickly do it. If you were running out of time, at least eliminate some quick ones, and then it wouldn't have been as much, and you got a 50-50 if you can't work out the next bit. Okay? Okay, Sam owns a printing machine. The printing machine depreciates by using a flat rate depreciation. So you can see I've gone to my formula sheet and found flat rate. Okay, so as I said, it says flat rate, so we know we can go to the flat rate formulas. So it goes the value of the machine in dollars after N years. So this is a yearly formula. Can be modelled by the recurrence relation. So it says recurrence relation because when we write it like this, with the initial amount as VO, and then how we get the next term with the VN plus 1, that's called a recurrence relation. Okay, So they're just going to give you some questions indicating whether you understand what that formula means. So what amount in dollars does the value of the machine decrease in every year? You just have to read that formula. What is it? Yeah, good. So 15,000. Showing recursive calculations determine the value of the machine after 2 years. So what you have to do there is you have to show that V1 would equal the original amount minus 15,000. Okay? And then you end up with... Okay, so you've got to write it like that, and then you've got to show that V2 would be minus another 15,000, which is 90. So that's me showing recursively, step by step, how you get that. Okay, what is the annual flat rate percentage of depreciation? So when they ask what's the annual flat rate, what they're actually looking for is we've called our percentage rate R. So if you look up here, can you see in our formula for the D value, you could either way, up here, we've got R in there. Now we know what that D is. What are they subtracting every year? Yeah, so we could write this, if I wrote this formula out here, but then what I could do is I can use solve, because I'm going to say 15,000 equals R, which I don't know, over 100. But do I know what VO is? Yes. And you could, once you get that, remember if we have an equation with just one thing we don't know, we can use our solve function and find out what R is. So R equals 12.5%. Okay? So the value of the machine in dollars after n years could be determined using this rule. Okay, so they're asking us for the nth term here. So that, if remember I said the middle column shows us the nth term formula. So here, they're saying they want you to write it out. And if you wrote it out, write down the rule for Vn. So you can see they want you to do it, and it is the same as what we've got up there. So we go Vn would equal, let's just say, follow what our formula says, and it says to write the VO. So what was the VO? 120,000. We can read that at the start. Now minus, now what was it? It says N times D. What was our D in this example? Yeah, so we write 15,000 and we'll just put the N there. So really, this was the A value that they wanted, and this was the B value they wanted. But you just had to write it out and you would have got it right. Okay, the Yarra Grove Wool Factory has 48,000 balls of wool to ship out to surrounding retailers at the end of each year. The number of wool remaining in the factory after N weeks can be modelled by this recurrence relation. So you've got a thing, so you know this is the start, and then every week 3,500 get moved out. Okay, recursion can be used to calculate the number of balls of wool remaining at the factory after 2 weeks. Complete the calculations by writing the appropriate numbers in the boxes. So this was like before we had to show recursively. They've pretty much stepped it out for us. So in this first box, what do we take away? What number are we taking away? Yeah, 3,500. And then when we go to find in the second year, we write what we have, and then we minus that again. And what would that be? That's like that. And that's all you have to pop in. Now, how many balls of wool does the factory ship out each week? How many? It's just the 3,500. They're just asking to see if you understand what you're doing. And the number of balls of wool remaining in the factory after N weeks. So when they ask that can be determined after N weeks, they want the nth term formula, which is this one. It's not exactly flat rate, but when you're minusing the same amount every time, can you see how flat rate has that minus. It's always the same amount taking away. So you know you've got this type of formula. So we have to write, if we're writing the nth term, we have to substitute in what VO is in here. So what was VO? 48,000. And then we can see, yep, we have n times what the D is. So what's D's got to go in here. So what's that? Yep, and there's that answered for you. So it says the factory continues to ship out the balls of wool at the same rate. After how many weeks does the number of balls of wool remaining at the factory first become less than this? So there's a couple of ways you could do it. You could just keep clicking it in your calculator, or you could actually, because you have the nth term formula where we had, so it was 48,000 minus 3,500 times n. Now, because we want the value to be this, we can pop that in here, and we can, then what we want to find out is the n. We want to know how many weeks it is. So you can see there, once I've got it like that, it's in an equation, and I could solve it like that. So you could do it that way, or you could have just kept clicking in your calculator if you wanted to, until you got down to how many weeks was it. Okay, so at night, this gets you 9.2. So at 9.2, it's 15, so it's not less than that. So therefore, we're going to say 10 weeks. A machine is purchased for 30,000. It produces 24,000 items each year. The value of the machine is depreciated using unit cost method. So now I know it's unit cost. After 3 years, the value of the machine is this. So this was like the question before. So we've got V3. They've told me a value. Okay, and now it says write the rule for the value of the machine after n units. So that's the nth term. They want this. So you could see when we write that out, we have to use VO, which I can see is 30,000, they told me. And then it's minus n times D. So once again, I need to work out what this D is. So remember, here's the formula that we could use. So the amount it depreciated, or sometimes I like to write the amount it dropped over amount of uses, yeah? So if you looked at it, it went from 30,000 down to 18,480, so that will give you the drop if you minus them. And the amount of uses, it was 3 years, so it was 24,000 every year. So if we do that, what do we get D to be? So I got that to be 0.16. So the final formula would have been 30,000 minus 0.16 n, which is E. Okay, Marlon plays a guitar in a band. He's paid $3,264 for his new guitar. The value of Marlon's guitar will be depreciated by a fixed amount each concert he plays. So this is another way of saying unit cost. So this is another way of saying unit cost depreciation. Oh, sorry. Okay, so after 25 concerts, the value of the guitar will have decreased by 200. So they've told you how much it dropped by. Okay, what will the value of the guitar be after 25 concerts? So you just had to do 3,264 minus the 200. So it was $3,064. Okay, write a calculation that shows the value of Marlon's guitar will depreciate by $8 per concert. So if you remember, this is the D value. So amount it dropped divided by number of uses. So in this case, it had dropped by 200 over 25 concerts and equals 8. Okay, the value of Marlon's guitar after n concerts can be determined using the rule. So that is, they want the nth term formula. So we know when we look up that on our notes, we have to write VO first. So what was our VO? 3264. And then it's minus, this should be our D value, which was $8. The value of the guitar continues to depreciate at $8 per concert. After how many concerts will the guitar first fall below 25,000? So you can either keep clicking, or let's do our solve again. So I'm going to say solve when the value equals this, and this is my formula. And we're going to go comma n. What does n equal? Okay, so it ends up being 95.5. If you go to 95 concerts, it's not going to be below. So you have to always go to the one. If it's a little bit over, you have to go to the next concert. So we're going to say 96 concerts. Okay, with this one, you're sort of going to have to trial and error. So this is the sequence here. And if you look, we know the first term is 5. If you were doing this formula, the way you would get the next one is you'd say, all right, you do 5 times the one before. So 5 times 5 minus 8. What does that equal? 17. Okay, so that gave us the second one. If we were finding the next term, we would have to do 5 times 17 minus 8. What does that equal?
77.
Okay, so it equals 77. Is that the next sequence? No, so that one's out. What about this one? This one would be 3 times 5 plus 2 does equal 17. But if we have 3 times 17 plus 2, 53. So is that it? Which one is it? D? Let's have a look. So we're going to say 4 times 5 minus 3, that equals 17. Then 4 times 17, which is, what's 4 times 17? And then minus 3 is 65. So that one works. And does the last one work? What's 4 times 65 minus 3? 257. Okay, so this one ends up being at D. You just have to check them. Richard will join Rosalind on holiday. He will sell his stereo system to help pay for his holiday. This stereo system was originally purchased for $8,500. There's a VO. Richard will sell his stereo system at a depreciated value. Richard used a flat rate depreciation method and let SN be the value of his stereo system after N years. The value of the stereo system can be modelled by this recurrence relation. So using the depreciation method, what is the value of the system after 4 years? Okay, with this one, because it doesn't say you have to show recursively, we would just do this one on our calculator, just like we did the question before. And we're going to see it after 4 years. So I'll pause and do it. So this one ends up being... Okay, what is the annual interest rate? So this is... Okay, so with this one, they're trying to find the annual interest rate, which is the R. So what I'm going to use, remember this was flat rate, so I've gone to flat rate. Find a formula that has the R in it, which we can use this D. Now remember, this is our D value there. So if D is found by doing this, well, I can pop in, I know what D is. R is what I'm trying to find, and I also know what VO is. So I can write all that in and press solve, comma R, and I can get the annual interest rate. So I got the rate to be 10.2%. So just make sure you write your answer. over there. Okay, question 21. The printer was purchased for $680. So when they say purchase, always good to put VO. It'll help you remember. After 4 years, the printer was at a value of that. So you could write V4 is 125. On average, 1920 pages were printed every year during the 4 years. The value of the printer was depreciated using a unit cost method. So the depreciation value, so that is that D value is per page. So you would have gone, hopefully you've gone and you've gone unit cost. So we'll go get the unit cost formulas. Okay, so I've gone here, I know it's unit cost, and they want the depreciated value, which is this D value. So I'm going to use the formula again. Now, it is the amount it's dropped by, so it's gone from 680 down to 125. So if you minus the value it was and is now, that'll tell you the drop in value. Now, it was over 4 years, so it's told me that every 4 years, every year it printed that amount. So when you work that out, it's probably going to be in a dollar amount. So okay, so I get that to be 0.07. So that's in dollars. So how many, what is it? So 7 cents. Okay, Alex is a mobile mechanic. He uses a van to travel to his customer to repair their cars. The value of Alex's van depreciated using a flat rate method. So they've told you flat rate. And the value of the van in dollars after N years can be modelled by the recurrence relation, and there they've showed us there. And okay, recursion can be used to calculate the value of the van after 2 years. Complete the calculations below by writing in the appropriate numbers. So this is pretty easy. So in this first box here, what are we subtracting?
3,375.
Okay, and then what's in the first box? Yeah, 625 minus 3375, and what does that equal? What was it? Beautiful. Okay, Alex is a mobile mechanic. He uses his van to repairs. This is the same question. He uses in the flat rate, and there's a recurrence relation. We know. By how many dollars does the van depreciate every year? Yep, you're simply reading it off. And calculate the annual rate of depreciation. So we're going to use that formula from our annual rate, and we're going to say 3375 equals the rate over 100 times, and we're going to go solve.